totally fine. Alright.
Who am I switching?
I can switch it.
Hello? Alright. Yeah, you can switch.
It's a fifth desk.
Yeah, thanks for
Thank
telling
you.
me that. So that makes it way easier.
Bergman and Riley, check the office,
I'm
please.
so confused right
The
now.
superintendent's office.
I don't have my glasses today, so me and Brown's.
Oh, okay.
Stop, what? You want, please? You bothered me.
Thank you so much.
Okay, ignore the section number. I forgot to change it from last year. New book. That should work. Sorry, missing some merging here today.
How's it come up?
Johnny, thanks, Nina.
No, don't be there. They told me like, I will literally never talk to you. That's all. Yeah, I didn't even get on him. But you already do that, so. You're giving me a
Yep.
I am.
Alrighty.
Don't talk to
Let's see, who we missing today? We're missing Frank, Trevor, Riley, Rachel. Is Rayleigh, is she a junior or is she
She's a freshman.
freshman? So she just must be gone today.
Kayla's
And
not
then
here.
Kayla. So, and then Ben. Is Ben? Is he a junior?
Yeah, back to June.
Ben's a junior. Okay.
Oh, never mind. Maybe Michaela's here. She was just in there. Maybe she was homesick. Yeah.
That could be.
Yeah.
Um.
No. She got one period again.
Let's see.
She's sick every day. You said she was mom. Oh, there she is. Hi, Michaela. We were just talking about
Perfect.
you.
Okay. Thank you very much. All right. Okay. Today, ignore the section number. Sorry, I should have modified that. I'll try to modify that before tomorrow because we'll probably won't get finished with this PowerPoint. But we're on section 1.6 today. We're gonna move on. We're gonna finish up the construction stuff tomorrow. I think that was just a good idea for a Friday. We might finish this PowerPoint tomorrow, and then we'll go into those constructions. Okay. 1.6 is on polynomials. Okay, that's what we're going into. Or not polynomials. What am I going? Polygons. Jeez. Polygons. There you go. We're going into the different shapes that most people think when they associate with geometry. We talked about the basic stuff, right? Lines, rays, segments. We talked about angles. But we haven't really talked about polygons. And those are the shapes that most people associate with geometry. And then eventually in this class, the later chapters, not chapter 2, but like chapter 3 and chapter 4, we start exploring, geez, what is wrong with this projector? We start exploring the different types of polygons. That's what we eventually look at, okay? So, the goal today, we're going to look at a lot of vocab terms. The first thing we're going to look at is definition of what a polygon means. It's a little bit different according to your textbook versus what an actual polygon is, so I'll try to clarify. Then what we're going to do is after we go into that, we're going to look at specific types of polygons. Okay, and not the classifications, but types of them. There's two different ways you can draw a polygon. That's what I mean by type. So we're really looking at how to draw them. And then the last thing that we'll try to get through today is we're going to look at the classifications. That's what we're going to really look at today. Okay, the classifications are all the different names that most people think of when they think of different shapes for geometry. Okay, does that make sense what we're doing today? Okay, ignore the section title, that was last year's chapter. It's been moved up a little bit. Okay, let's go through this and let's see what we can do here. So, alright. So, I wish I could hit play. Is it possible I can do that? Nope, guess not. Okay. Kinda odd. Alright. But here's the main thing that we have. Polygons. This is the definition. According to your textbook, and I put in air quotes, it's composed of many angles. Alright? That's what your book says. Many angles. Okay, that definition is rubbish. It's no good. So the idea is that it doesn't even explain what a polygon is. It just says it has many angles. That doesn't make any sense. So the idea is it's composed of a couple different things. So there's a couple of different things that are very specific that we need to make sure that we draw the pictures correctly. Okay? So number one, when you're composing or you're drawing a polygon, it's made of coplanar segments. Well, that should make sense. If you're drawing a figure, a two-dimensional object, all the segments that you're drawing, because they're segments, not lines, but segments, they have to be on the same flat surface, the same plane. That's common sense, right? Most people think of that. Now, the other thing that we need to talk about is that there's certain stipulations with these segments. And these are the things that the book, they allude to, they talk about it, but they don't really ever put it as a formal definition. Number one, what your book says, segments have to hit two or more other segments. So each stick of your picture has to hit two or more other sticks eventually. That's the minimum size, two or more. So if this one stick, let me draw this. If this one segment here, because it has to be a segment, has to hit at minimum two or more others, what's the minimum number of sides I can have? If this thing has to hit two or more others? 3. That'd be the minimum size. It'd be this. And what is that object? Triangle. That's what it's explaining. That every wall has to hit two or more other walls eventually. So that's check mark number 1. That's common sense. Okay, so we're going to have at least, this is the minimum size for something that's a closed figure. Okay, number 2. They have to intersect. So when you draw these walls, they have to intersect at the end points. They cannot intersect in the middle. So none of this type of drawing. I do not want anything that looks like this. No bow ties. Okay, where the lines cross over each other. Or a situation where you have something like this. And let's put it down up here, down here, and it comes down and it crosses up. Like none of that type of things. Okay, no line should ever intersect each other without hitting at the endpoints like this. Everything touches right at the endpoints. It's very hollow on the inside, that type of thing. Okay, so that's check mark number 2. Okay, and then number 3, no segment with a common endpoint are what they call, quote unquote, and I'm going to move this over just so you can see this, quote unquote, are what they say collinear. I don't know if you can see that. No segments with common endpoints are collinear. So what they're basically saying is that when I draw a figure, I cannot have something that ends up being like this. Where the endpoint for these segments right here, this is the one that causes a problem. I don't want ever 2 segments that are straight lined with each other. There has to be a bend in the road. Okay, now why there needs to be a bend in the road and it can't be straight? It's because what is the definition? It has to have many angles. Many angles. Okay, I don't want straight angles. I don't want straight. I want an angle in the road. So it has to be something like obtuse, right, acute. No straight angles. Okay, and that was check mark number 3. Okay, now, all that does, and this is something that, I picked up when I was reading your textbook, this is just something that I picked up that explained how to draw it very specifically. Okay, you got segments, they connect to endpoints, they're not overlapping, very nice and very easy. Okay, any questions so far on this stuff? Okay, now let's talk about the last two things. The last two things are actually vocab terms. It's not a definition. These are actually words that I'm going to use for these pictures. Okay? So I'm gonna go back up here and I'm gonna go to this original picture, this triangle that you guys are familiar with. The points of intersection, where the two walls meet, right? So where two walls meet, this is called a vertex. That's what we call it. Most people call them the corners, but it's a vertex. Now, if you have more than one, which we do, how many vertexes do we have here? 3. When it's plural, you pronounce it vertices. Vertices. It has 3 vertices. Vertex is singular, vertices is plural. Okay, are we comfortable with that word if I start using that a lot? Alright, it's going to be one of those days, isn't it? Or not. Okay. So I hate this Apple TV. It will be on tonight. Alright. So it looks like I'm going to have to write the rest of this. Okay. Fair enough. Alright, so we had the word vertex. Okay, that is the intersections of those segments. Okay, now the second word, if you did get a chance to copy it, was a segment, right? Now, anyone happen to catch what the definition of a segment was? Anyone see what that last line said? No, it didn't? Okay. It is a side of your polygon. So if I start using segments, we could, it's just the side. That's just a big fancy word for what they're talking about. It's the side. Now, sometimes we have a different word for a segment. Sometimes we'll call them edges. So that's if I start saying, hey, what are your edges? How many edges do you have? How many segments do you have? That type of thing. They mean the same thing. So these are your basic items. If you combine these objects, you can make any type of polygon that you want. That's the concept. Okay. Any questions on the basic vocab here? Perfect. Okay, so let's move on. We're going to talk about the different types of polygons. This is how we basically draw a polygon. Okay? Now I alluded at certain stipulations. The segments couldn't be in a straight line. They had to intersect at endpoints, that type of thing, and they had to be coplanar. Those are obvious, but these are very specific. Number one, okay. The basic types is that we have convex type of polygon versus concave. Now, I know some people have heard these terms in like the science class. That's fine. I'll try to give you the definition according to geometry. Okay, let's start with the word convex. That's our first one. I'll try to write it a little bit bigger. Got a little small there. Okay, when most people draw a polygon, this is actually the type that they draw. It's convex. You don't even realize it. That's what most people think as. Okay, so a convex. I'll give you the formal book definition, and then I'm going to draw a picture to explain it. no interior points connected by a segment will pass through the exterior of the polygon. Okay, now, I'll explain what that means here in a second. So, no interior points when you're connecting them with segments will cross the outside of the picture. This is the most common way we draw convex type of polygons, the basic polygon that we have. So the first figure that I had drawn on the board was that triangle, right? This picture of this triangle is convex. And the reason being, according to the book definition, I hate the book definition, but that's what they said, was you pick any two interior points. So interior points, you connect them with a segment. Did that line cross the outside of the picture? No, there's no way. There's no way that could have happened. Okay? So I could have moved this anywhere. Okay, it didn't matter where my 2 points were, when you connect them, it won't pass it. So no interior points connected by a segment will pass through the exterior of the photo. Now, concave, they can pass through. Okay, so does everyone have that drawing, that basic drawing down? That's convex, right there, that's what most people think of. I always think of convex as like a big fluffy pillow. There's lots of space on the inside. That's just how I think of it. Okay, so now let me show you concave. I'll give you the definition, then I'll draw the picture and you can see the differences, and I'll put them side by side. So concave. It's basically just, we take out the word no. Interior points connected by a segment will pass through the exterior of the polygon. Thank you. Alright. So, concave, it's basically just straight out the word no. So now when I connect a line connecting two interior points, it somehow crosses the outside of the photo. You're probably wondering, how is that possible? So let me draw a four-sided figure. Now what do most people think of when you think of a four-sided object? Square, right? Square, rectangle type of shape. Okay, this is what most people have in their head, some form of this object. That object that you're looking at there is convex. That's what most people have in their head. It's a convex picture. I can put two interior points. When I draw a line, it won't cross the outside. Now, I'm going to draw something that most people do not think of about a four-sided figure. That's still a four-sided figure. Most people do not think of objects like that. Okay, that's a concave picture. So in fact, let me clean this up a little bit, and I'm going to put it really big right here next to it, just so you can see this. Okay, it's like the Star Trek symbol if you're a Trek fan. There you go. Alright, so that's a four-sided figure. It's got 1, 2, 3, 4, 4 sides. But this picture is considered to be concave. Concave. How I think of concave, it's got a cavity. It's got a cavern, like a mouth. So there is a cavern here, it's a little cavity. Okay? So the points are like moved up in the inside. So now when I draw two interior points, so would you agree that those 2 points are on the inside of my photo, my picture, right? When I draw a straight line that connects them, a segment, do you see that it crossed the outside? That's what makes it concave. Now I know some people will go, well, why didn't you just move the points up? Yeah, you could do that, but if it's possible to draw 2 points and connect them with the line and it crosses the outside, that automatically makes that figure concave. Automatically. most people do not think of objects like this. Like, when you thought of a four-sided figure, did you have that image in your head? No, hardly anyone ever does. How I always remember these objects is like, the image I always have in my head when I'm describing these is like, if you're really familiar with, like, if you watch a lot of movies, like Tim Burton films. Tim Burton did like Beetlejuice, he did Big Fish, Willy Wonka and the Chocolate Factory. He's got a really weird, eclectic style of film. Like, every object in his movies are never like, they're never symmetrical. So when you look at like a house, the house is somehow always, you know, leaning, things aren't right, like something's weird with the house, like the walls are tapered, they're never 90 degrees. The doorways are never matched up. It's just his style. Because everything he does he's always thinking of how can he make a picture look concave as much as possible. So maybe the doorway, instead of having it, you know, squared off, he might have a doorway that looks like this in one of his movies. He always tries to make concave because it stands out more. It's his style of film. Okay, it's very different than like a Wes Anderson. Wes Anderson did Moonrise Kingdom or something like that, or the Royal Tenenbaums. His movies are perfectly symmetrical. When you see a scene in his movies, the actors are perfectly balanced. There's always symmetry to all of his photos. Like when you watch his films, like everything is perfectly aligned. So when he has a scene, it's very like staged where they're standing, what things are in the shot itself. But a Tim Burton movie, everything's just crazy. Everything's everywhere. It doesn't make any sense. No rhyme or reason to it. So that's how I think of this. It's like Tim Burton versus a Wes Anderson, kind of like a shot. So if you're in film or photography. Okay, any questions with the two words? Now, in this class, we focus primarily on convex. That's what we focus on. The properties we learn in like chapter 3, chapter 4 are based on these objects, not these. The reason being why we don't ever focus on these types of objects, they don't share the same properties like interior angles, and they don't share those types of properties, because when you look at this object, let me go back to the original. Like when we look at interior angles, that's really small, that's small, that's small, but what about this angle? What type of angle is that? What type of angle is that? It's bigger than obtuse. It's a reflex angle. It's like past 180. It's past straight. So we do not do properties based on concave. We just don't. We don't do that. Okay? Alright, any questions so far? Now these are types, so it's just a way of drawing it. So it's just a particular way. Now, the next thing I want to discuss is the actual classifications. So these, now there's going to be a bunch of vocab words here. These are the different shapes that most people associate with geometry. These are the different types or classifications of them, the different shapes involved. Okay, so here we go. Here's all 10 that we basically focus on. The first category, so classifications. Wish I had my PowerPoint. It'd be a lot easier doing this. Number 1, first type is the one you guys said earlier, the triangle. Triangle is the first type. It is the minimum shape you can draw using the definition of a polygon. Polygons, each wall has to be connected to 2 or more others. So the minimum shape you can draw, if this segment has to be connected to 2 or more, so if it's connected to 2 others, that's the minimum shape you could have as a triangle. There is different types of triangles. In fact, there's like 7 different names we can call triangles. And that's the stuff we might go into tomorrow. Because when we start actually drawing things, using our compass and straight edges, there's 7 different types of triangles. So that's something we need to look at, see what the words are. Okay, is everyone comfortable with the first type? Okay, second type. What do you think the second word is?
Square.
Nope.
Quadrilateral.
Quad, yeah. Quadrilateral. Now, most people think square, they think rectangle. Nope. Okay, it's a quad. There's how many different types of quads. 1, 2, 3, 4, 5, 6. There's like 6 different types of quadrilaterals that we're going to eventually discuss. So, quad meaning 4. So 4 laterals, laterals or sides. Triangles, there's 3 angles in that object, that type of thing. So they're not real creative on the naming. Okay, any questions so far on those 2 shapes? We will eventually go into the names, look at the specific properties of those. Maybe tomorrow we might go into triangles. Eventually we'll hit the quads and we'll look at all those different shapes. Okay, those are the most common. Those are the ones we will spend most of our year on, is those 2. That's what we spend most of the year on. There's certain things we learn about the others, but primarily in mathematics, that's where all of our focus is based on. Because you can break down any object into these 2 shapes. It's just it's a combination of these 2 put together to make other shapes. Okay, now if we go to the next type, what most people think of, the pentagon. The shape for a pentagon is 5. Penta is Latin for 5, right? What does that object look like? Looks like the outline of like a house. The most iconic photo of a Pentagon is the Pentagon Building in Virginia. The Pentagon Building in Virginia is very specific. The walls on the outside are exactly the same size. Like they're exactly the same length. The angles in the corners are exactly the same length for that building. And even the courtyard, there is a courtyard in the middle. It is exactly a miniature replica of the outside. It's got, 5 walls, and they're exactly the same with the same angles. That type of thing. So it's just an iconic building itself. This building, it's every wall's the same, every angle's the same. It actually has a name for it. It's actually called a regular, which is goofy to me, but it's called a regular pentagon. And that's a vocab word I want you to know right now. The word regular doesn't mean what you think it does. The word regular in geometry means all angles are the same, all wall lengths are the same. Any object that I put on the board today could be regular. Congruent segments, edges, congruent angles. All of them have to be the same. If one's different, it's not regular anymore. Which to me, this is totally goofy. That's like in English, regular just means plain, generic. But in geometry, it means something special, in fact. Okay, so that's Pentagon. The next shape that we have, anyone know it? Hexagon. Hexagon. Hexagon, how I remember hex, it has an X in it. What number has an X in it? 6. That's how you remember it. It's the easiest way to do it. Hexagon looks like this. There you go. What does that object look like? And don't say a stop sign. Because it's not a stop sign. Because that's what I know most people try to think of. It's not a stop sign. Honeycomb. It's what bees form their hives in. It's always a hexagon. Protein crystals come in hexagon shapes. So I think bacteria, when you look at like a microscopic zoom on bacteria, they always come in hexagonal shapes, which is weird. Something that happens in nature. Okay. Okay, that's a hexagon. The next one. There's 2 different names. I'll give you both. Heptagon or septagon. Latin versus, I think it's Latin versus Roman. So, heptagon and septagon mean the same thing. They mean 7. seven-sided figure. Seven sides could be, you could be building a house and you just put an addition on the house, that type of thing. So here's the 1, 2, 3, 4, 5, 6, 7, there you go, there's your house. Okay, now what type of shape is this? Is this convex or concave? Concave, it's got a cavity, it's got this, it's fine. It's still a heptagon or a septagon, whatever you want to say. So, but it's got 7 walls, 7 edges. Okay, next one. Octagon, I think it's a good name. Another spelling on it. Hey, got an A. Look goofy, put an O in it. Octagon. Octo means what? 8. Octopus, 8 legs, right? 8 tentacles, whatever you want to call them. Okay? Octagon is the stop sign. So 1, 2, 3, 4, 5, 6, 7, 8. There you go. 8 walls, that's a stop sign. What you'll find is like in Department of Motor Vehicles, DMV, they use the different polygons here to mean very specific things. Like triangles are always warnings. Things that are quads are usually like informational signs, you know, speed limits, something like that. Stop signs, iconic, it's the only shape that would be an octagon. But I don't think there's any other shapes that they would do. Usually it's warnings are always triangles, quads are always informational, and then icons a stop sign.
Use Pentagon for the crosswalks.
Yeah, the
School
crosswalks, yeah, so that's almost a warning too. That's weird because it has a triangle on the top of it. It's a quad with a triangle on the top.
Maybe it's like warning and informational.
Yeah, it's just informational, I guess, so. Okay, alright, now, next one, this one's the weird one. A 9-sided figure. It's a nonagon. A lot of people don't know that name. Because if you look in random textbooks, some textbooks will say nonagon, some won't. That means 9-sided. Some textbooks will say a 9gon, like this. They don't get real creative. You can actually say that for all of these. 3gon, 4gon, 5gon, but these have specific names. I'm very surprised that some textbooks don't put nonagon. I think the reason being is that this is Roman and most of the other ones are all Latin. So that's why septagon I don't think was found in your textbook because it's the Roman version. They don't put those. Okay, 10-sided figure. 10-sided, in fact I'll put it over here because now we're getting a little low on the board here. Ten-sided is decagon. Deca meaning 10. I mean, that's what all metric system uses. It's in, decimeters, decameters, they're in versions of tens. So, that's why the metric system is actually just kind of an easier system to work than, the US customary system. But decagon meaning 10 in Latin. So, 10-sided figure, again, you could just draw 10 walls, connect them. Okay, 11gon. Most textbooks will put this, right? 11gon. There is a different name though. There's a different name other than 11gon. Hendecagon. Hendecagon. A lot of people won't see that because it's not found in most textbooks. Hen meaning one more than a decagon. So. And the last one. Dodecagon. Dodecagon is 12. So 12gon. After that, there's no other names. There's no creative, names for those polygons. They'll just call them 13gon, 14gon, 15gon. But these are the ones that have specific names. I don't mind, like when you get to Nonagon, if you use 9gon or 11gon, you use that. But these are the basic ones we're gonna be looking at some point, like there will be problems where they give you a picture, we'll have to find, what certain angles on the inside are, there's certain formulas we're gonna have in this class that will help you find that. But for the most part, throughout the whole entire year, we focus on these top two. I mean, we learn a lot of properties about triangles. I mean, that's the basic study of triangles is actually called trigonometry, study of triangles. And then quadrilaterals is something we do focus on. So we'll eventually talk about, area. If we make it a 3-dimensional object, we'll talk about volume. But we mostly focus on those two for a lot of the parts. And then eventually in this class, we'll eventually get to the conic sections. Those are different types of shapes. Conics are circles, cylinders, cones, that type of thing. Spheres, if you go 3-dimensional. Okay. Any questions with these basic objects? Okay, now we only got about 5 minutes left. Tomorrow for sure, right when you walk in tomorrow, I'll probably do a quick recap of what these are, but tomorrow we're gonna focus on the triangle. That's what we're gonna do, because we're gonna look at taking the compass and the straight edge and drawing like the 90-degree angle, so we can make a 90-degree triangle or a right triangle. Then eventually we'll look at a 60-degree triangle and what that means. Okay, that type of thing. Okay, any questions, comments, concerns? Okay, perfect. You're done for the day. I know page 50. I said it was due today. If you need another day to work on that, if you want to turn in tomorrow, I'll totally accept that. Okay, if you need one more day to work on that. The reason being is I forgot to review. I want to go over tomorrow. Even if you turn in now, that's fine. If you're done. Tomorrow, I want to go over number 5 in class, and I want to go over number, I think it's 27 in class. We're gonna do those tomorrow. Okay? Does that make sense? Okay, so if you want to turn that page 50 in tomorrow, I totally understand. Because it's not a big deal, I won't get it graded tonight anyway, so I just know that, so. Alright, there you go. Now I gotta figure out what's going on with this. Apple TV.
She'll bring like the eggs and I'll bring the whatever. When's the test over the workout? The test over the workout? She said that you tried calling her. She said that was like but it's weird.
Is it chaos and juice? Maybe go closer to your face. What?
I was just wait.
I was like,
Oh yeah, K.
chaos and juice and maybe go closer to his face. That's the one I always forget.
Thanks, sir. Yep.
I have this down.
I have take no trace here, Mom. I'm happy for the English. I had to go the last year's. It was fun.
Oh, I still have one. Me too.
Oh, yeah, I'm a morning
Going down there and asking if I can do it. I'm doing that today.
Wait, is this sweatshirt still? Like a dress
No,
or
I
something?
know, I was
That's
not.
just a cap. What am I talking about? It's like gusto.
Did you say Ghana?
I said gato is a cap, isn't it?
I thought you said cow. It's not a cow. Okay. She said cat.
No, I feel like I'm breaking it.
It's like we're gonna follow
Thank you. I'll take it. Thanks.
So, Brandon Carolyn, Dash City, Markla, Caleb Renner, Connor Shaw, Spencer Berger, Reba Winkleman, Alex Statlander, Colin Schoenman, Madison Taft, McKay Shropshire,